Our enterprise consists of 6 project teams with approximately 5 to 7 members on each team. We currently have 4 sponsored projects which we will be diving further into in a moment. Projects typically last between 2 and 4 semesters, but some have been operating continuously for several years now. Approximately 1 in 3 members of the enterprise will hold some sort of leadership role, either acting as a member of senior management, a project manager, or smaller leadership role on their teams.
The goal of the Autobot team is to build and program a robot for the Intelligent Ground Vehicle competition, which is focused on autonomous obstacle avoidance, line tracking, and GPS navigation. The Autobot project repeats after the robot has successfully completed at least the qualifying round of the competition. The current iteration of the project, Charlie, has been going since 2016. This semester, the Autobot team has been working on setting up a new processor for the robot, updating drivers for the robot's hardware, and converting old C++ code to Python. This clean slate will help us ensure that coding best practices are used and that all hardware and software on the robot is up to date. Next semester, we plan to test the code on the robot and further prepare for the competition in summer 2021.
The Slipring Testbed Team is a team operating under the Blue Marble Security enterprise. The Slipring team is sponsored by Deringer-Ney, a company leading the market in the development and production of electrical contact parts and assemblies. A slip ring is a combination of a ring and brush that allows for a connection between a rotating component and a stationary one. It allows for the transmission of an electrical current between the rotating and a stationary assembly for the purposes of transmitting data or power. In this configuration, a brush set contacts the outside diameter of a ring, which can rotate freely while still in contact with the brushes. The objective of the slip ring team is to design and fabricate a testbed that is both compact and modular, and can evaluate the performance of slip rings over long periods of time. Currently, the design of the slip ring testbed is nearly completed, with only small changes to increase the ease of manufacture or to minor details of the assembly such as cable management remaining. Manufactured components are being sourced locally to decrease lead time and facilitate communication. All of the necessary sensors have already been chosen and purchased, and all of the major components of the testbed will be ordered soon. The team is also working on coding the LabVIEW suite that will both record data from and control the testbed. By the end of the semester, the testbed should be ready for assembly and trial testing. In the end, developing this testbed will allow Deringer-Ney to evaluate its existing products before delivery and facilitate future design and development of slip rings.
Hello, my name is Jordan Wolf, and I'm the project manager of the Oshkosh LCV suspension design team. My team has the opportunity to design, manufacture, and install a utilitarian suspension system to the Oshkosh Baja LCV, or light concept vehicle. My team is also presented the opportunity to subject the system to standardized tests pertaining to the vehicle handling, ride quality, and performance requirements. These opportunities allow the team to foresee suspension design undergo all stages of development and testing. The team has completed several phases of the project, which entailed designing manufacturing, installing, testing, and developing improvements to a suspension system. Currently, my team has been repeating, testing, and developing the suspension system after noting failure during vehicle testing. My team continues to locate and resolve failure sources to meet vehicle handling, ride quality, and performance requirements.
This is the cost-effective vision pick-point system sponsored by General Motors. Here, we apply machine vision in conjunction with a robotic arm to cost-effectively ease the process of manufacturing. An implemented bench-scale model of the GM pick-point system was created that could detect objects quickly and accurately. It has built-in error detection with machine learning that can both classify and localize the objects in question. For example, the neural network was trained with images that could accurately identify Duplo blocks. Using the camera, the blocks are identified and the regions are outlined.
I'm Michael Stock, the project manager for the Predictive Failure of Steel Galvanizing Line project at the Blue Marble Security Enterprise at Michigan Tech. This is a sponsored project by ArcelorMittal to reduce downtime on their galvanized steel production line in East Chicago, Indiana. The production line produces tens of thousands of time-varying signals. Our goal for this project is to develop software that actively monitors the line and predicts when future downtime may occur. Currently, we are working on our production line monitoring software. The goal is to create a base framework for the software and deliver it to ArcelorMittal with the core functionality needed to predict some future problems with the line. Once our monitoring software is being used by ArcelorMittal employees, we can get feedback that will guide future development.
Blue Marble Security's outreach team's overarching goal is to create events that engage and interest youth into STEM and Blue Marble Security itself. Due to the nature of this goal and project, every semester we create sub-goals to advance our position towards our primary goal. This semester has been set up to focus on researching 3 new events: the Arduino Levitation Project, the MBOT Project, and the Catch LED Project. Due to the recent worldwide pandemic, our goal is to prepare these projects as best as we can to be finished and tested early next semester.